guys, this is Pushkala and this is the video on computer vision and image processing. So what is image processing? You will take an image and you will threshold the image, or you will try to segment one thing from the another from the image, or you will try to convert the image into black and white. These are something that comes under image processing. So when you take an image to process it so that you can view the details clearly, or you want to do something with the image, process the image and everything, you can do with the computer vision libraries in Python. So that is what we are going to see today. So how to use this computer vision library in Python. So the computer vision library that I've been talking about is this one, OpenCV library. So you can install this by saying pip install OpenCV Python. So this is the library I've been talking about. So I have imported that library saying import CV2. So from this library, I need some other libraries to support me. So I'm going to import NumPy and Matplotlib. So NumPy will help in all the numerical processing, and Matplotlib will help you to visualize the images and everything. So that is what the libraries that I require right now. So I've imported all the necessary libraries. Now I'm going to proceed with reading one of the images I have. So cv2 dot imread. Image read is the function that is going to help me read one of my local files, local libraries. So this is the image. When I print this, it is going to print some of the matrix slice format. So this is a 3D image. When you have 3 brackets here, you can see this is a 3D image. So what I'm going to do is, when I say 3D image, it means it is a RGB image. So what I need is, I need to convert this into a 2D image, which is black and white image. So when I do 0, 0, now I have turned this image, brain tumor image, into a black and white image. So I'm just gonna see the shape of this. So as you can see, this is a 167 cross 176 black and white image. When I say nothing here, this is a RGB image. When you have 3 channels here, which means one is red, blue, and green, which is a RGB image. So let us go for black and white processing. Because the image I have is going to look something like this. I'll display the image and I'll show you how it looks. I'm going to use Matplotlib to display this image. So all I'm going to do is, I am show image. That's all. So this is my image. It practically looks like a black and white image. So I no need to add any other colors here. So there is no need for RGB here. So I'm just going to say 0. So this is a black and white image, and it somehow Matplotlib processes black and white in RGB as well. That is why it looked like this. So to change this into normal, I'm gonna say CMap equal to gray. So you can see this is again back to normal. So this is same as the RGB I just showed you. Since the image is all black and white, I don't need it to be processed in 3 dimension. 2 is fine. So the next thing I'm gonna do is, I'm gonna implement some filters. I'm gonna show you how that filters work. So first, this image is a normal RGB image. Even if I blur this image a little bit, it will still retrieve the tumor. And it will reduce this coarse material inside. You can see here there is a lot of unnecessary pixels. I don't need that. So it will just increase the amount of processing, but it will not do me any favors. So what I'm gonna do first is I'm gonna blur this image to remove the unwanted information. So for that, I'm gonna assign a variable called blur and CV2. In CV2, I have a function called blur, and in this, I'm gonna say image, that is the input image. I'm going to give a 2x2 filter. And I'll again show you guys how this image looks. Again, I'm gonna say CMap. Great. So there is not much of a difference here, but the number of pixels and the coarse material you see inside is not here. At least it is blurred a little bit. So I can focus only on the main information, the skull information, the main lines in the brain, and this tumor material. I don't need any of this unwanted coarse material. So I have blurred the image and extracted only the information I need. So blurring is done. CV2.blur will give me the blurred images with 2x2 filter. And the next thing I'm gonna do is I'm gonna threshold this image. Thresholding is a very important concept in machine learning. Why? Because thresholding will set a scale where when you cross a particular point, it will be completely white. Or when you cross a particular point, it will be completely black. So I'm going to set a threshold in such a way I'm going to see only the main material between this black and white images. So you will need two variables for this, RET1 and threshold1. We are going to use the threshold1 variable only anyway. Threshold, I'm going to use the blurred image here, which is a processed image. And I'll let you know what is this 127 and 255 because I need to print this so I can finally show you guys what it is. I'm just using binary threshold because this is a grayscale image. Caps lock. I am sure threshold 1. I'm gonna say CMAP. Great. You can see this. So this is my blurred image. This is the input image where I see too many coarse material and I'm removing that and I'm retrieving only the important information here. So this is my blurred image. Using that blurred image, I have extracted this black and white threshold. So you might think, what is this 127 and 255? So when I turn this one to 0, you can see all the black material disappeared. And when I turn this to 255, it is totally black. So this is somewhere you will work with how much of black you want to see. So that is why I have given 125. So this is how much of black I want to see. And this is how much of white I want to see. When it is 0, it is completely black. When it is 225, it is how much of white I want to see. If you want to reduce how much of white you are seeing, just reduce the number here. So this is better. So this is only the main curves here that is being retrieved and the whole tumor. So all the wanted materials, all the main margins from the images have been extracted. This is called thresholding, and what I have done here is a binary thresholding. Binary threshold is nothing but you will be working with only the black and white images. So this is binary threshold. Change here. Binary threshold. This is the ratio of black and this is the ratio of white. Adjust it manually according to the image. So you will get how much of the black and white contribution should be there in the image. So the next thing I have to go for is adaptive thresholding. So what if I don't know the exact threshold? I want to adaptively set a threshold. So this is a big game. Playing with black and white so far is a big game. So let us reduce the effort here. So that is adaptive thresholding. So here I'm gonna take threshold number 2, TV2. I have a library called adaptive threshold Gaussian. Gaussian is nothing but we are assuming this is a normal image. Or I'll just go with threshold first. Okay. Adaptive thresholding. I've given the spelling wrong. Okay, yes, this is the library. Adaptive threshold. And inside that, I'm importing the blood image again. And I'm gonna say white ratio is 255 from the previous cell. And I'm gonna do a adaptive threshold, Gaussian. And as we already know, we are using a binary image. So I'm gonna go with threshold binary. I'll tell you what that 19 and 2 is. So I'm gonna show the image again. Map. Great. So this is better than this, isn't it? I can see the outlier of this white material very clearly in here. The boundaries are very clear, and from this, I don't see any of the internal material clearly. In here, in the normal thresholding, I don't see any internal material very clearly as well. But here, I can see all the internal material of the prime clearly. So for this, what we have done is, let's change this 19 to 0. And let me tell you what happens. If this is not accepting a size of 0. Okay. See, the thickness of black has been reduced. So again, this is the ratio of black. So when I say 20, it is not adapting to that filter. So I'm going to say 19. So this is the final material. The thickness of black line inside this, that is what we need. 11. So this is better. Although you have some unnecessary white here, to merge that, I'm going to increase this filter. 19 works fine. Yes. And this 2 is nothing but when I change this to 0, everything again is black. So I'm going to reduce that black. So this is nothing but how much of black and white you're going to see. Most of this is about extracting only the black and white ratio that you need. So when I see 2, all you're going to see is bunch of white. Inside that you will have a margins of black which represents the diagram image. So this is adaptive thresholding. You can play with these two numbers as you want to get the image that you like, the sharpness inside the images, the finite line inside the images that you need. So when we talk about image processing, we mainly go for 3 filters. When we talk about neural networks or when we talk about image processing, computer vision, we need 3 filters. One is to extract the shape. One is to the first filter extract the main shape, and the second filter try to see what is the finite lines that is inside that is making up the image, and the third filter will retrieve more finite lines from the image. So that is what we have done here. From the image, I have extracted the main cell. From that, we have gone to extract more minute features, and from that, we have extracted more minute features. So this is the final code. So this is the final code. I have explained so far. So we have read a brain tumor image, and from that we have blurred that image. I have used that blurred image to do binary thresholding, the black and white image threshold. So how much of black should be in the image, how much of white should be in the image. That is binary thresholding. To make the binary thresholding one step ahead, we'll go for adaptive thresholding. In this, you will see the very minute lines in the brain or any specific images very clearly. That is adaptive thresholding. So see you guys, and if you have any doubts, leave it in the comments. Thank you.